Okay, today what we're going to talk about are functions and function notation. A couple things that we want to talk about when we're discussing functions. Functions can either be discrete or continuous. A discrete function consists of points and are not connected. Okay, so if you have points, if points are just given, you don't necessarily have to connect those. And continuous, they're graphed with a line or a smooth curve. And we saw some of those in our examples that we've talked about. The next thing that we want to talk about is called function notation. What you're pretty much used to are functions that are generally written as this: y equals 3x minus 8. That's what you're used to up to this point, seeing that, picking out the x values so you can determine the y values. But what we're going to do is we're going to switch out that y, and we're going to notate it as this: f parentheses x equals 3x minus 8. And the way we say that is f of x. That's the way we say that. It can be f of x, it can be g of x, it can be h of x, it can be anything of x, okay? Doesn't necessarily have to be f, okay? So if you see it notated different ways, that's what we do. Now this can be confusing at first, but really all it's doing is it's saying this and this are the exact same thing. Okay, so it's saying the function of x equals 3x minus 8. So what that means is, if we have, for instance, the function here, f of x equals 2x minus 3, and then it says find each value, f of 1. What that's saying is that f of 1, we have f of x is 2x minus 3. F of 1 equals 2 times 1 minus 3. So we're substituting basically that 1 in for the x value of the function. So then we can just do the math and we can say 2 minus 3 and we get negative 1. So the next one I'm going to do is the next one down, 4c, and it says f of negative 2. So f of negative 2 equals 2, substitute in for the x value that you see up here, 2 times negative 2 minus 3. And we have negative 4 minus 3, and you get negative 7. Now we have 6 minus f of 5. And when you first look at that, you're like, holy moly. But this is all it is. 6 minus the entire quantity. And then we go back to our function. 2 times 5 minus 3. So I have 6 minus 10 minus 3. And 6 minus 7, which is negative 1. Really not that bad once you understand what this f of x is actually doing. Now I have f of 1 plus f of 2. So I'm going to substitute it in. So I'm using that function twice in this expression here. So I have 2 times negative 1 minus 3, and I'm going to put parentheses around that whole thing. This is our answer for the last problem. And then it says plus 2 times 2 minus 3. So 2 times -1, -2 minus 3 plus 4 minus 3. -2 minus 3, that's -5, plus 1 is going to give us -4. Okay, so we can also use functions. Now this was a linear equation, or this was a linear function. We could graph these points, we could go ahead and say and figure out what it was and graph the points and go from there. Now we also have functions. We also have functions that are nonlinear. Okay, that means it's not going to create a straight line. It's a continuous function, but it's nonlinear. So I have f of 4. Here's my function right here. F of t equals 2 times t to the third. So if I have f of 4, I have 2 times 4 to the third. And I go ahead and I figure that out, and I have it being 2 times 64. And we end up with 128. F of -5, 2 times -5 to the third. So it's going to be 2 times -125. And we get -250. So then we have 3 times the quantity f of t plus 2. So that's kind of fun. So I'm going to write it as 3 times 2t to the third plus 2. And all I can do here is say 6t to the third plus 2. That's all I can do. And finally, I have f of -3, function of -3, minus the function of 1. So I'm going to say 2 times -3 to the third minus 2 times 1 to the third. So I have 2 times -27 minus 2 times 1 is just 2. So 2 times -27 is -54 minus 2, and we get -56. If you have any questions whatsoever, please put them in at the bottom or on the back of the page and record those questions down. Thank you.